Good day everyone, we are the Group 5 and we will explain the circles and lengths of a segment. Just keep on watching for you to learn something.
Good day to everyone, my name is Dustin Neo Moral and today I will be talking about the 2-second segment theorem. So let's start.
Good day everyone, Group and Noval here, your third reporter.
Good morning, I am Princess Anne Mijares, reporter number 4.
Good evening everyone, I am Dajjal Davidson Mayol and I am the 5th reporter.
2-second segment theorem. It is stated that if 2-second segments are drawn from the same exterior point, then the product of the lengths of 1 second and its external segment is equal to the product of the length of the other second segment and its external segment. So notice in our theorem it is 2-second segment. So to better understand, let's have this illustration. So in this illustration we have 2 seconds, 1 and 2. The product of the lengths of 1 second, so this is our first second, which is W. Let's put W here. And its external segment. So this is our second segment, and this is our external segment, which is X. So W times X is equal to the product of the length of the other second segment. So here is our second segment, and this is the other second segment. The other second segment, which is Z. So Z times its external segment. This is our second segment here. Our second segment, which is Z, and here is our external segment, which is Y. So Z times Y. Now let's repeat. The second segment, which is W, times its external part, that is X, is equal to the other second segment here, which is Z, times its external segment, which is Y. So here is our formula in the given theorem. So let's use this theorem to solve some problems. So we need to solve this problem. We need to find the value of X. So to find the value of X, so here is our problem. The circle, and this is 2 seconds. Now, so the other second segment, this is the total length of the second segment, this one. So we're gonna write 6 plus 4x. Why? Because the total length of the other second segment is 6 and 4x. That's why we're going to write 6 plus 4x times its external part, which is 6 here. This one. That is our external part. So let's repeat. The total length of the second segment, which is 6 plus 4x times the external part of the segment, which is 6. That's why 6 times 6 plus 4x is equals to the total length of the other second segment, which is 6 plus x plus 3 times 6, which is the external part of the other second segment. Next is we need to distribute. So 6 times 6, that is 36, and 6 times 4, that is positive 24x, is equals to 6, and we need to add 6 plus 3, that is 9. So we're gonna write 9 plus x. So 36 plus 24x is equals to 6 times 9, that is 6 times 9, that is equal to 54. 6 times x, that will be positive 6x. To solve for x, we need to transpose it. That is 24x times 6x is equals to 54 minus 36. So 24x minus 6x, that will give us 18x, is equals to 54 minus 36, that is 18. So for x, we need to divide 18 itself. 18 divided by 18, that will give us 1. So that is our final answer. So the value of x is 1. So that is our 2-second theorem.
So in this theorem, it says that the length of the other segment, so we have 7. We're going to add this will 7 plus 5x, wherein this will be the total length times its external part, which is 7. 7 is equal to the total length of the segment, and same thing as what we're gonna do to the other side. And the outcome will be 7 times 7 plus x plus 2. So simply distribute 7, and this will result 49 plus 35x is equals 2. Well, on the other hand, we must combine first the like terms, which will result 7 times 9 plus x, and then distribute 7, which is 63 plus 7x is the outcome. The next step is combine like terms or transpose like terms. So this will become 35x minus 7x is equals to 63 minus 49. 35x minus 7x is 28x equals 63 minus 49, which is 14. So in order to cancel 28, we must divide both sides by 28. So cancel 28 and bring down x is equals to 14 divided by 28, which is 1/2. So our final answer is x is equals to 1/2.
So we have here tangent second segment theorem. So this theorem states that if a tangent and second segment are drawn from the same exterior point, then the square of the length of a tangent segment is equal to the product of the length of the other second and its external segment. So to illustrate our theorem, let's say we have this circle and we have a tangent segment and a second segment. So the square of the length of a tangent segment. So our tangent segment here is q. So we'll have q squared is equal to the product of the length of the other second. The product of the length of the other second is s, our total length, times its external segment, which is r. That's why we'll have x squared equals s times r. So let me give you an example regarding this theorem. We have here our tangent segment which measures x and our second segment 7 and the external part 9. So following our theorem, square of our tangent segment is equal to the total length of a second, so 97, times the external segment of a second, so 9. So x squared equals 9 times 9 plus 7 is 16. And x squared is equals to 9 times 16 is 144. Now we'll get the square root. So the square root of 144 is 12. The square root of x squared is x. So this is our final answer.
So in this example, you must study the circle. So here we have a tangent segment and a second segment. So following our theorem, we have the tangent segment. Therefore, 15 square is equals to the total length, which is 12 plus x times the external part, which is 12. So let's distribute. 15 square is 225 equals distribute 12. So we have now 144 plus 12x. Combined like terms, which will result 225 minus 144 equals 12x. So we just simply transpose 144 to the other side. 225 minus 144 is equals to 81 and simply copy 12x. So to cancel 12, we must divide both sides by 12. Just bring down x and divide 81 by 12, which will result 1.5, which is our final answer.
Hello guys, today we're going to talk about two chords. So what is a two chords? A two chords is a two-line intersecting in a circle. And as you can see here, I already drew it because so it won't waste my time. So as you can see here, two chords is two lines intersecting in a circle. So right here. And then in the first chord, what I put is A and B. In our second chord is 2 and C. In the second chord is C and D. To get the formula of two chords is we're going to get the first and the second ratio. And as you can see here, our first ratio is A over C and D over D. To get the formula, we're going to cross multiply A times B, C times D. So the formula here is AB is equals to CD. And if you're asking if these both triangle, these both lines are congruent to each other, so I may answer that question. So the answer is yes, they are both congruent. Because as you can see here, these both lines are triangle, and if we put one line here and one line there, and as you can see, they are both congruent and they intercept the same arc. Yes, they intercept the same arc. That's why these both triangles are congruent. They are all the same. So now we're going to head to our answer, to our question. The question here is how to get the x. How to get x. Okay, to get x, we're going to do the formula. The formula is AB is equal to CD. So since The second curve is the x. We're going to put 8 times 12 here. 8.12 is equals to 16 times point times. So what is 8 times 12? 8 times 12 is 96. So 96 is equals to 16 point x. Now we're going to divide 96 divided by 16 and 96 divided by 16. So 96 divided by 16 is 6. So x is equals to 6. X is equals to 6. That is the answer. So the answer here is 6. Thank you for listening, and that's all. Thank you.
So to fully understand the topic, let's have this example. So let's shortcut the method. 16 times x is equals to 10 times 8. So let's multiply 16 and x, which will result 16x is equals to 10 times 8 is equals to 80. So to cancel 16, we must multiply each side by 16. So the 16 is being cancelled. Bring down x equals to 80 divided by 16 is equals to 5.